All right. So typically, this is how we'll go ahead and get started. I'll just kind of give you an update on how things are going to be, as far as like next week, this week, things that are happening. So when you walked in today, one of the documents picked up was going to be your next assignment. In fact, the first assignment I believe I've given you, correct? Yes, okay. So this assignment here will go with the current lesson. We're going to be able to wrap that up today. And you'll notice I've already given you the notes for the next section, which we'll go ahead and start tomorrow. And I'll talk more about that when we get there. I'm hoping we should have some time to go ahead and work on the assignment in class, maybe do one together. We'll kind of see how that works out, but it really depends on time and the number of questions we have. But yeah, this homework assignment, I'm thinking, let's go ahead and make that due tomorrow. Okay. And then we'll see how much time we have in class, and we may need to change that later. The assignment. Okay. The frequency table, box and whisker plots assignment. Okay, and then on Thursday, this is the material that we're going to have our first quiz over. So there'll be a frequency table problem, a box and whisker plot problem. Nothing too terrible, I don't think. Very straightforward, in line with what we've been doing. The one I'm really looking forward to is next Thursday. What's that? That's the exam number 1. So it's going to have the frequency tables, cumulative frequency graphs and tables, box and whisker plots. More than likely, probably standard deviation. Depends on how far we're able to get, but we'll definitely go ahead and start that next week. And did everybody get my text yesterday? The practice one? Yes, you got the picture that accompanied it? Yeah, okay, I usually do that. When I send out a reminder, I always send out some kind of little joke that accompanies it. So, not only do you smile because you got a text from a math teacher, but it's a joke as well. Yay. Again, very quiet in here, very awkward. Okay. Just in case you didn't sign up, it's right on the back board over there, the very bottom, Math Studies, at FK6CD6. I think we're all signed up for the website. The videos, first videos are posted. Those are taken care of. So does anybody have any questions? Anything you want to talk about? Okay, then let's go ahead and get to it. Yesterday, we started talking about an introduction to statistics, which kind of played off of what we did last week, talking about sampling the population, analyzing the data, and we started to look at it to do that. We got how to break up the data, whether it's numerical, descriptive, measurable, countable, and then we started talking about frequency tables. Okay, and we kind of skirted the idea about normal distribution, but we're going to go ahead and wait on that just a little bit more. Okay. What was relative frequency again?
Correlated is like the total and not percentage.
It's the percentage. There we go. Because the frequency is just the number of times that event occurs within a particular scenario or whatever it is that you're referring to. Your survey, things of that nature. And I believe, okay, that's as far as we got. Okay. So let's see here. Our next problem. So we were working on class intervals. A sample of 20 juvenile lobsters was randomly selected from a tank containing several hundred. The length of each lobster was measured in centimeters, and the results were. Okay, so let's go ahead and finish up this tally and frequency table. So how many of the lengths were between 3 and 4? And we're talking centimeters here, or it doesn't say? Okay, looks like we're just talking about units then. Okay, so how many of those values are in the first class interval between 3 and 4? Okay, 2? I got 3. Okay, I got 3 on that one. So we have our tally marks, and then our frequency is 3. Okay, so how many items or elements are in the set? No, in the entire set. 20, so there were 20, okay. And then, of course, if we wanted the relative frequency, we'd take the frequency for this particular class interval, divide it by 20. We'd have our percentage. All right, what about between 4 and 5? I got 6 on this one. So 1, 2, 3, 4, 5, 6. All right, and what do you guys think for the rest of them? Between 5 and 6. Okay, I got 5. Would you guys agree? Okay. Do we want to run through the data real fast? Just take a look. Or are we good? Okay. So let's see here. Between 5 and 6. So here's one right here. Moving along. 5 is included. So we're going to take that one. We have another one right here. And we got another one right here. Did I miss one? Yep, 5.8 right there. Okay, so I got 5 on that one. 1, 2, 3, 4, 5. And then how many of the elements are going to be between 6 and 7? 4. There we go. And last up, we have 2. So I'm going to 4, okay, and then 2. And I'm going to make that a better 4 because that's a horrible looking 4. And now the frequency, all those should total 20. Okay. So is everybody okay with what we've been doing yesterday? Okay. Easy, right? Okay. We're about to get into the good stuff in just a second, finding the measures of central tendency and finding box and whisker plot. So it's a little more involved. Okay, so it says in a frequency histogram. Okay. Oh, and that seems to have been cut off here. But in a frequency histogram, there is no space between the bars. The values at the end of each bar represent the class width, and the center of the bar is at the center of class width. Okay, so what was the highest frequency that we got? Okay, 6. So my vertical here is going to represent the frequency. Okay, so we'll just go ahead and count these by ones. 1, 2, 3, 4, 5, 6 would be right there. Now, how are we going to go ahead and represent these class intervals showing up on this, the horizontal? Like, what's the minimum value in the first class interval? 3. Now, we can actually go ahead and start at 3 if we want to, but, we can go ahead and just label and rewrite the axis however we see fit. So we could just go ahead and say 3 is right there. 4, 5, 6, 7, 8. So that way everything works out perfectly for us. Okay. And then, remember, I just stated it, but what was the difference between just a normal bar graph and a histogram? There you go. The histograms are what we're going to use because we could be dealing with continuous data. Okay, so we're not going to have no space between them, but if it's a bar graph, then it'll be discrete. So we have to have a space between those bars. Okay, so let's say between 3 and 4, we had a frequency of 3. So I'm going to go up to 3. Let's see how well I can draw my bars. Okay. Between 4 and 5 was 6. That was the highest one. Oop, cut it a little too short there. Bless you. Okay, 5 and 6 is going to give me 5. So that's just a little bit short of that one. Between 6 and 7 will give me 4. So let's say maybe right here. And then, of course, between 7 and 8, we're only going to get 2. There we go. Now, one of the things that's going to be really useful to us if we're dealing with class intervals is using the midpoint. Because a lot of times, here we were actually given the data, but if we were just given those class intervals and told the frequency without seeing the data, we actually wouldn't know what the values themselves are. So a lot of times we have to use the midpoint when dealing with these. In fact, it says right below, add a frequency polygram to the histogram. So a frequency polygram is just a curve that connects the top of these bars. Specifically, we're going to go ahead and connect them at the midpoint. Okay. And then we'll just go ahead, let's say it starts right here. Bless you. There we go. So that's what we're going to refer to as a frequency polygon. Okay, does that make sense? Okay. Now, let me go ahead and do this because the paper doesn't actually show it, but let's say, as I was just referring to a second ago, you aren't given the data. Now, how do you find the mean of the data? How do you find the mean, the average of a set?
You add them all up.
You add them all up?
How many you have.
And divide by the total number of items in the set. So I take the grand total of whatever that sum is, divide by 20, and I have my mean. Okay, but a lot of times, like I said, you're not going to know what that data is. Let's say we were only given this table right here, so we have no idea. In a case like this, if your data is divided into class intervals, you're given the frequency, but you want to go ahead and figure out what's the mean, you're going to have to use the midpoint of each of these class intervals. Okay, we'll have to get a total and then go ahead and divide that by 20. So let me show you what I mean. What's midway between 3 and 4? 3.5. So I'm going to go ahead and say this is 3.5. Now I'm going to multiply that by 3. Because how many of the elements are in that interval?
3.
It's 3, right? And see, if we don't know what the data is, then we have to make our best guess, our best estimation. And the midpoint's going to be the one we want to use for that. So somebody help me out. I need 3.5 times 3. 10.5. So I'm going to go ahead and put 10.5 right here. And then we're going to do that all the way down. Okay, so halfway between 4 and 5. 4.5. And the thing about these, you know, your class intervals should be of equal widths. So you should be able to tell the pattern very quickly, so you don't always have to find the midpoint between them. You can just keep moving forward. But what am I going to multiply 4.5 by? 6. So what would that be? 27. Okay. Is everybody seeing how I'm doing it? Okay. Now I'm going to take the midpoint of the next interval, which would be 5.5, multiply it by 5. What's that give me? 27.5. Okay, next up, between 6 and 7, I'm going to have 6.5. Multiply that by 4. 26. And 1 to go, 7.5 as the last midway value, midpoint, times 2 is 15. Okay. Now, we have notation for everything in mathematics. The mean is going to be typically represented by x, because x represents a specific element in your set. And if we put a bar above it, that refers to the mean. That's telling you we want to find the average. Okay. So somebody help me out. We need to add all these up right here. 10.5 plus 27 plus 27.5 plus 26 plus 15. Anybody grab a calculator on the way here? What is it? 106. Okay, so Gabby, you're saying 106? Okay. I don't have a calculator. I'm just going off what you guys are telling me. Okay. So how would I find the mean? Now take that total we got from the frequency and go ahead and divide by 20. So I do have my calculator pulled up here. Calculate. So it was 106. We're going to go ahead and divide by 20. So I'm getting the average length to be 5.3. Okay. That's the mean. All right. So if you ever have a frequency table, you don't see the data, and you are asked for that average, this is what we want to do. Okay. Any questions? Not too bad, right? Okay. All right. Let's see what else we got. Histograms on the calculator. I'm probably going to wait a day or two to go ahead and show you on the calculator. I'm going to have you work by hand first, get accustomed to it. Then I'll go ahead and start showing you the calculator. Because, you know, I talked about this the other day. I really think if we just focus on the calculator, you know, you're not getting the full picture. You know, you're not making a connection. Okay. All right. So let's go ahead and take a look at box and whisker plots. And if I'm not mistaken, I believe this is our last page, and we'll be done with our first set of notes. Woohoo! Okay. Box and whisker plots. So we have quite a few bullets here. The minimum value, okay, minimum. The lower quartile, Q1, the median of the lower half. The median is what we call Q2. The upper quartile, Q3, is the median of the upper half. Then, of course, we have the maximum value. So I believe it may be listed on your homework here on the back where it's talking about the box and whisker plots. Okay, so take a look at number 6. It's not on these particular notes, but if you look at number 6, A1, it says construct a 5-number summary. Okay, that's just IB talk for saying I want these 5 right here. I want the minimum, the maximum, the lower quartile, the upper quartile, and the median. That's what it's referring to. Okay, they just call that a 5-number summary. All right, I just wanted to go ahead and point that out because it's not on the notes and I didn't want anybody to get confused. The interquartile range, IQR, the range of the values in the box, is found by taking the upper quartile and subtracting the lower quartile. Now, don't confuse that with the actual range. The range of the data is the difference between the maximum and the minimum. Okay, so the IQR, the interquartile range, is just the difference of the upper and the lower quartiles. And then I think we talked about these the other day, or at least we brought them up. Outliers, extraordinary data that are usually separated from the main body of the data. Outliers are either much larger or much smaller than the rest of the data values. So let me ask you a question. Let's say you're gathering your information for your IA, however that data is. Do you want to include or exclude outliers? Exclude? Would you guys agree? Okay. I would say include. Because will that outlier definitely have an effect on the rest of them? Absolutely. And if we were to go ahead and omit that, then, we're introducing some bias because we're only looking at data that could be, say, favorable to us. I mean, just think about your average. Like, let's say you do a really good job of always turning in your homework and you go ahead, it's like a 100, 82, 90. They're really high grades, right? But let's say one day, you got busy, but you weren't able to go ahead and finish. Okay? So unfortunately, the 0 goes in the grade book. That's an outlier. Will that affect your average? Absolutely. That one drastically different value from the rest. Okay. And then we have a test for outliers, the lower boundary and the upper boundary. What we do is we take the lower quartile, Q1, and we subtract 1.5 times IQR. What was the IQR again? The interquartile range. Okay. And then the upper boundary is Q3 plus 1.5 times IQR. So I'm going to go ahead and help you show you how that calculates as soon as we do this. So we have a set of data. Let's go ahead and create a box and whisker plot. All right. So use the data to make a box and whisker plot. So find the minimum, Q1, Q2, Q3, the maximum. What do we call those? The 5-number summary. Okay. And then we want the IQR and any outliers or outliers, depending on how you go ahead and pronounce it. I always say outliers. So you'll notice sometimes it's going to be really nice and the data will be ordered, but you'll notice this is what? The data is not ordered. So what is the smallest value we have? 2. So I'll tell you what, I'm going to go ahead and start with the 2 down here. Is that the only 2 we have? Okay. So then it looks like we have 3 here. Anything else? No. So 2, 3, and hopefully I'm giving myself enough room here. 4s.
3.
I'm counting 3. So 1, 2, 3, 4, 4, 4. Any 5s? I count 2. Okay. So 5, 5. 5, 5. Let's see, 6s.
5.
Okay, 5 of them. So 1, 2, 3, 4, 5. Ooh, we got close. What if there was only 3 6s and we put 6, 6, 6? Yeah. Okay. That would have worked better had it been like closer to Halloween or something. But I stick by it. My jokes are good. Now somebody laughs. Really, that's what you laugh at. Okay, how many 7s do we have? 7, 7. I like that. My jokes are funny. Okay, I'm sorry. All right, so what's up next? 8. How many of those? So it looks like we have 2 8s and a 9, and I just have enough room here to get all those taken care of. All right, so I've rewritten the data in order from least to greatest. All right, so as far as the 5-number summary, I'll just go ahead and put that up here. Here's my min, and I always like to go ahead and do them in order. So then I would have Q1. What do we call that? The lower quartile. Then we have, I'll just put Q2. That's my median. Then we have Q3. Whoop, if I can write today, that'd be great. Which is the upper quartile. And then we have our maximum. Okay. So the max and min are super simple. What's the minimum? 2. We have the maximum at 9. Okay. Now, how many elements are in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have 17 items total. So we talked the other day about the numbers always going to be represented by n. So I'll just go ahead and say n equals 17. Okay. So how am I going to find that median? Much easier because this is an odd number. So how much on each side should I go in? There you go. I'm looking for the innermost number, right? Okay, well with 17, okay, I want to go how far above and below? 8. So 8 and 8 will make the 16. So 1, 2, 3, 4, 5, 6, 7, 8. So the ninth one should be the median. Because see, I have 8 below and I've got 8 above. Okay. And you could also, just take 17 and divide by 2. What's half of 17?
8.5.
Okay, 8.5. So I need the 8.5th term or ninth term. Okay, if you want to go ahead and do it that way. So here's what we're going to do. This one's my minimum. This one's my maximum. Okay, so I've got the lower half of the data and I've got the upper half of the data. Okay, well, how do I find Q1 and Q3, the upper and the lower quartiles?
Negative 1.5 and.
Oh, no, that's for the outliers.
Oh.
So we don't need that yet. So let's take a look up here. So like Q1, what's it say? The median of the lower half. So the lower half of data, I just want to go ahead and find the middle value again. So this time we have 8 terms. So what do you do if you have an even number? There you go. You have to take the average of the innermost 2 terms. So see, here I'd have 3 above, 3 below. So 4 plus 4 divided by 2. So 4 is going to be my lower quartile. Is everybody okay how I'm figuring these out? Okay. So now I want to do the same thing for the upper. What would be Q3? 7. Okay, so again, being 8, I'd have to take the average of the inner 2 most values. So that is 7. That is Q3. This is Q1, and of course Q2 is going to be 6. That's my median. Okay, well now we just want to go ahead and put this along my line graph using your box and whiskers notation. Now, can these only be horizontal? Okay, now typically you've probably only ever seen them as horizontal, but is it very possible just to go ahead and list your data vertically? Yeah, your line graph would have to be vertical as well, but there's nothing wrong with that. Okay, so that's perfectly fine. So let's see. Let's start with my quartiles. Q2 was 6, so I'm going to draw a little line segment right here above 6 because we like to have a huge rectangle connecting the quartiles and the innermost of this graph. The lower quartile was 4. Okay, so that's the left side of my rectangle. The upper quartile, Q3, was 7. All right. There we go. Is this coming back from previous classes? Okay. And then, of course, the whiskers coming off the rectangle is going to be your maximum and your minimum. So we had a maximum of 9. And what I like to do, like when I get to 9, I go ahead and do that. That's how I always was accustomed to doing it. But, I mean, some people like to go ahead and stop with a dot. In fact, you'll see a lot of graphs like that. What do you guys prefer? Whichever? No preference. Okay, I've already got a dot, so I'll leave it as a dot. And the other one, the lowest value is 2. So there we go. Here is the minimum. Here's the maximum. Here's Q1. Here's the median. And here's the upper quartile. There we go. So that's your box and whisker plot. That's all there is to it. Now, what it does is, again, it's giving you a way to visualize the data. Specifically, what's it doing? How is it breaking the data up? Think about it. Why do we call these quartiles? Okay. Well, what percentage is a quartile?
5%.
It's what?
25%.
25%, right? So what it's doing is it's breaking it up into fourths. So we're saying that between the minimum and the lower quartile, whatever elements exist there, that represents 25% of the data. Does that make sense? Okay. And then it just breaks it up. Okay. Well, what's the only thing we have not done? And you mentioned it a second ago. Okay. Well, no, we don't have to find the mean here. Okay, the outliers. Okay. So let me go ahead and erase this. Okay, now the lower quartile, okay, the lower boundary, I'll just go ahead and say LB for lower boundary. I want to go ahead and take the lower quartile Q1, and I want to subtract 1.5 times the IQR. Okay, and then for the upper boundary, okay, I'm going to go ahead and take Q3, and I'm going to add 1.5 times IQR. Now, let me ask you a question. What's the range of the data?
The maximum minus the minimum.
Okay, so that would be 7. Okay, so the range is simply the largest minus the smallest. So the range is simply 7. But now, what is the IQR? Okay, the IQR is going to be the upper quartile minus the lower quartile. Okay, so IQR is going to be Q3 minus Q1. So yeah, somebody said it, 7 minus 4 is 3. So we want to use the value of the IQR in the formula here. Okay, so let's see. Q1 was 4, and I'm going to subtract 1.5 times the IQR. So 1.5 times 3. So 4.5, and what's 4 minus a negative 0.5? Would everybody agree? Okay. Now let's do the other one. Q3 was a 7. All I'm doing is plugging into the formula. So if you're looking for the lower, you're going to subtract. If you're looking for the upper, you're going to add 1.5 times 3. So what's this? We already know that's 4.5, so plus 7? 11 and a half, so 11.5. Okay. These represent the boundaries that you're looking at. Okay, so if I were to mark them on my line graph, negative 0.5 is going to be like somewhere right here, and 11.5 is probably going to be somewhere right here. Now, you only have an outlier if the data extends beyond those boundaries. Okay, does either my maximum or my minimum go beyond those boundaries? No. So what can I say about this data? There are no outliers. There's no one value that would be considered radically different from the others. Okay. Now, just to go in a what-if situation, let's say everything remained the same. Let's say we did get our maximum boundary at 11.5, and let's say that, the very last number we had in my set was 13. Okay. If an element goes above or below those boundaries from the formula, those are what's considered outliers. Okay. So is everybody okay with that? Okay. Does anybody have any questions? Yes, ma'am.
If it was 13 with Hutchins maximum.
Yes. Mm-hmm. So this whisker right here would be extended past it, and that's what you're looking for. Do the whiskers extend beyond those boundaries? Okay. All right, so like I said, that was just a what-if situation, but in this case, the whiskers were definitely within the boundary, so we're good to go. Okay, good. Any questions on box and whisker plots? No? And I think, there's the instructions on the calculator, and there we go. That is a different assignment. That's the assignment I had last year. I decided to upgrade for this year. But I'm going to go ahead and let you guys get started on that. Okay, so we have, about 18, 19 minutes, so a decent amount of class time, almost a third. Okay, but I do want to go ahead and show you this very quickly, because you picked up something else on the way in. This is going to start tomorrow's lesson. Okay, now by the time you come in tomorrow, I'm going to have this first table all filled in. I'm going to be ready to go. I'm going to ask you that tonight take 5 minutes. Okay, it shouldn't take any longer than that. You're given your set of data. I want you to go ahead and fill in the tally column, the frequency column, and then if you want to, you can go ahead and take a look at the cumulative frequency, but we'll talk about that tomorrow. Okay, basically the more of the table you have filled in, the more time, we can actually look at the problem and talk about it. Now, the relative frequency, is that something you can do? Yes, how do we find that again? That's the percentage. That's when I take the frequency of that particular element, the number of times it appears, and divide by what? The total. Okay. Now, cumulative frequency is a very, very simple idea, but it's very useful to us. It can help us find any percentile that we want. But if you can, tomorrow when we come in, I'm already going to have that ready to go. If you can just have that done in addition to the assignment. Okay, Eli.
Or for the tally, are we we like if we're doing the tally for like that first row, so
Uh-huh.
0.65, are we only telling values equivalent to 0.65?
Yes, yes. So this first one, we're looking at the data itself, and then once we have this all taken care of and we go ahead and figure out what cumulative frequency is, then it's going to say, okay, take the same data and now categorize it by these class intervals. Okay. All right, now this I'm not too worried about. We can go ahead and take care of that tomorrow, but that larger table, if you could take a look at that for me, please. Okay. All right, well, let's do this. Are there any questions on the homework you'd like to go ahead and work together? Maybe get one out of the way? I don't have a snapshot of it yet, but I can write it down. Okay, which one would you guys like? Or just start with number 1? Number 4? Okay. All right, so how about I get you started and I do like half of number 4? Okay. So let me do this. Ma'am, would you turn on the light real fast? This is going to go a lot better if I have the diagram and I don't have to draw it myself. I'll have this ready by tomorrow, but okay. Okay. Do it. Okay, so here is number 4, and let's see what it says. Okay, ma'am, if I get you to turn off that light again. Thanks so much. All right, so it says this frequency histogram illustrates the results of an aptitude test given to a group of people seeking positions in a company. All right, how many people sat for the test? So how can I figure that out? There you go. I'd want to look at the frequency. So everything's been broken into intervals. These are the scores. How wide are the intervals? Okay, there are 10 points, and it looks like what's the maximum number of marks you could get? 160. Okay, so how many people scored between 80 and 90? Okay, so 5. Between 90 and 100? 10. Next interval? 30. Okay. And see, here's the thing. This is a perfect example of what I was referring to. This is the first one where we don't actually see the data. All right. So did I mess it up? Oh, yes. I was just seeing if you were paying attention. La, 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 la. Okay. But we're just going to have to make our best guess. Because you notice there are 5 scores between 80 and 90, right? Maybe one of the scores is 80. Maybe one's 86. One's 85. But we don't have any idea. So when we're finding the mean, we have to calculate that using the what? The midpoint. There you go, of the interval. Then this one would be 40. If it will allow me to write the 0. 120 and 130 is 10. Then here we have 15. Then it looks like we have another 10 and 10. Okay. So in this case, the frequency represents the total number of people who took the test. How many am I looking at? I'm looking at 125 people if I take the sum of all of those. Okay, so A is taken care of. Now it says estimate the mean score for the test. Okay, this is just like I showed you on your notes. All right, we know the frequency. We don't know the actual values. So I want to use the midpoint for each class interval. So what's halfway between 80 and 90? 85. Okay. So I'm going to multiply 85 times what? 5 and get what? 425. Okay, and I'm going to want to do that for each of the class intervals. Okay, so the next midpoint would be 95. There you go, times 10 people, 950. And then I'm going to continue this. Okay, the next one would be 105 times what? 25, yes. And that would be 2625, 2625. Okay. And I'll let you guys go ahead and finish the rest of that. So once I have all those values, what do? I add them. So I'm going to take the total, okay, number of points that we got. Okay. Once you finish going through all those intervals, and what am I going to divide by? 125. When you do that, you'll be able to estimate the mean score. Okay. Caitlin, you okay? All right. Is everybody good? All right, so I'll go ahead. Listen, I set that problem up for you. You got the calculator. You still got a good 10 minutes. You could probably knock at least 2 or 3 more of these out pretty quick. Okay, the box and whisker plots are not very big. Okay.
Is the 90 to 100 section including 100?
90 to 100.
Is it like the 90 to 100?
Oh, more than likely the interval starts here. So the other one would probably go to like 99.
Okay, that's
And then the other one would start at 100. Okay. Because I'm guessing on this test, you're not going to get like a 99.7. Okay, a 99.3. It's going to be a 99 or a 100. Okay. So we can still label it as continuous even though we're not taking a portion of that. Okay. All right, good. So I'm going to take the extra copies that we have here, and I'm going to put them straight over on the door. Okay, so if you're ever absent, remember, you can look over here, get some extra copies if you misplace anything. Sure, go for it. You can also look on the website. All right. Thank you very much, guys. You did a great job today.